we are back at this and we are now looking at the measures of dispersion, which I don't want you to lose it thinking that this is going to be a lot. It will not be a lot. For measures of dispersion, remember that this is going to be very, very tiny. So try to make sure that you do not forget them because it is not much. Okay? This is not going to be a lot. So let me put it like this, make some space, make sure it's going to be enough. All right, so then I'm going to need space. Definitely I'm going to need space. So should be very fair here. All right, for our measures of dispersion, we are going to have, remember we are dealing with here ungrouped data, and they will deal with the grouped data. So this should not be hard. Okay, we should remember this. Please, this is something to remember. You practice, you concentrate, you focus, you do a lot until the formulas are in you and they're part of your system. So let's do these things. It's not hard. Okay, the first thing which I'll do is range. And range is just going to be something which is so simple, range R. And you only see it for here for our ungrouped data. So it's going to be the range. The R is just going to be equal to highest value minus the lowest value. Okay, highest value minus lowest value. And this gives you the range. Now that we will be knowing range, we can go to the next thing, which is going to be the interquartile range. So this one is not there. Now, the next thing is going to be interquartile range. And for interquartile range, this one is there for both grouped and for ungrouped because we can find quartiles for grouped, we can find quartiles for ungrouped. For ungrouped, we said it will be the medians. Lower quartile is the median of the lower half of the staff. Upper quartile is the median of the upper half. The Q2 is the median itself for the quartiles. Then for the median of group data, we saw how to get it. We saw that formula that we had, okay, where you have the lower class boundary of the quartile, whatever it is. Then plus, we put Jn over 4. We said minus the cumulative frequency of the class, which is before the one with the quartile. Then we divide it by the frequency of the quartile class. Then we multiply it by class width. That's the fraction which we had. Now here we have to find the interquartile range. It's just going to be Q3 minus Q1. And this is how we find the interquartile range. And it's the same for grouped and for ungrouped. Okay. Now we are going to the guy that is going to be important. Only one thing is going to be dangerous for you, and that is variance. We saw that for measures of location or the measures of central tendency, where we had one value representing our information and that value was trying to describe how everything is behaving. In here we have measures of dispersion where we have a value that tells us how different things are, how separated your values are. Okay, it's one value which is telling you how separated things are. It's not trying to unite them, it's showing you the separation. That is the measure of dispersion. Now, this measure of dispersion, the one which you must watch is variance. For measures of central tendency, we needed to know the formula for the median, for grouped and ungrouped. For grouped where we had it, we had the formula for mean, for grouped and for ungrouped. We had the formula for mode, for group, for grouped, especially for ungrouped. We were just looking for it. We have the formula for the quartiles for ungrouped and also for grouped because we use median. Then we have deciles, which were for ungrouped and quartiles. But there were many formulas, right? For group data, we had mean. For group data, we had the median. We needed the formula. For group data, we needed the formula for mode. We needed the formula for the quartiles. But in here, we only, for group data, special formula will be for variance. So I've said a lot just to make you know that variance, which is this next guy, is the dangerous guy. Okay? Variance. This is the guy where you are going to need to know formulas. Okay? They will be different for these two, but there's very much similar. We know just what changes. Very similar. Okay? And I'm going to say, if you go through your slides, you see two formulas. I'm going to show you one which you're going to use, which is the easiest. Okay? Now, variance, we should know sample variance and population variance. Just like we knew sample mean and population mean. Sample mean, we had it as an X bar. Population mean, we had it as a mu, a Greek letter. That's the same here. Population variance will be a Greek letter, but it will be sigma. Okay, population variance, it will be sigma. Okay, sample variance, this is for, and we still have again sample variance again for grouped data And we still have, again, population variance for grouped data. Population variance, which is just S sigma. Here, sample variance is going to be, this is sigma squared. This is going to be sample variance is S squared. This is going to be S squared because S itself is standard deviation. Sigma itself is standard deviation. All right, so, but it'll be for this thing. So whatever, here we have these two, and they are covering variance. So variance will only end after these two are done. So that is where we go to the next. For variance, for sample variance. Now, what you must just know is for variance, let's put it real quick. It's going to be equal to, for sample, you use n minus 1 on the outside only. Then for population, you use n. Okay? That is only for the outside one. You must know that. Okay, so this is going to be 1 over, we know that anyway, for sample, the n is also a small, so it's 1 over n minus 1. Then what we do is we put, so you see 1 over n minus 1. Remember, 1 over n minus 1. Then in here, it'll be 1 over n, which is sigma squared, is 1 over capital N. Then what comes after is interesting, because in here, you will now say the sum from 1 all the way to the last term, which here will be saying n, of x squared. There should be x squared. This I, don't let I fool you. I is just telling you that we are going to sum from 1 to something. Okay, we're going to sum from one point to another, which we will be knowing. But don't ever look at that I. Look at the x. What is it? It's an x squared. So we'll be summing x squared. Then we always subtract. So we first square, then we sum. Then we always subtract the sum, then the square. So here is going to be the sum, then you square outside. Will be from 1 to n. We sum, then we'll be squaring outside. So here you're going to square first, then sum. We subtract the sum, which is first, and squared. But this one should always be over n. It should always be over n. Here we said it's a 1 over n, and it's the same thing, summation from 1 to n of x squared, okay? Then we say minus the summation, okay, from 1 to n of xi, okay? This is now all squared divided by n. So this is going to be the thing. It's not hard, is it? This is going to be the formula, and that's what you need. I know that you can see sometimes in your slide this n being put as a 1 over n, but it just makes it confusing. Just keep it like this. This is going to be it. This is not hard. Is it hard? It's not hard, right? This is not hard. Let's do for group data what it would be. So variance, remember, is the big formula. After variance, we can take a breather. Then the others are just nothing. The others are just nada. So practice variance all the time. That's the important formula for measures of dispersion. Here we'll be saying this is a sigma, right? Here we'll be saying S all squared is going to be still 1 over n minus 1. Yes. But now, instead of an x, what do we put when we're dealing with group I where there was an x? We said we put w and f. All right, so here it was x squared. It will be w squared times f. F does not get squared because it's just telling you the frequency. So we say it is from 1 up to k, which is the number of intervals. Then you'll be adding wi, which is the midpoint in those intervals, times this. But it's going to be w squared times this. Then you say minus the sum from 1 up to k of wi times fi. Then you square outside, okay? You square outside. Then you divide by the number of terms, which is going to be n. Then this is it. For population, it's sigma squared is 1 over capital N. Then you just say the summation from 1 up to k of wi fi. Same thing, nothing changes. But this w should be squared minus the summation from 1 up to k of wi fi. Then the squared is outside. Then we divide by the total number of terms. Remember that this is also outside. This is not hard, ladies and gentlemen. This is not hard. I know you can do it. Come on. Just remember variance. Practice it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make it stick in you. Go and remember the measures of central tendency. Write them and write them and write them. Make them stick. And you'll be good. Okay? You will be good once you can remember them. Because the other things which we are now doing, which is the last 4 things, they are just one single thing. It's not even this big. This was the danger one. Variance was the danger one. Now that is it. Goodbye for now. See you in the next. We will meet in the next video. Thank you for watching. Goodbye.